Good morning, students. Welcome back. In the previous class, I started with the chapter Chemical Changes and Reactions. That was chapter 2. And in the previous lecture, we discussed about, if you remember, we discussed about the properties of a chemical change, the features of a chemical change, what factors are responsible to bring a chemical change, rather not only chemical change or chemical, to bring about a chemical reaction. So all these things, there are so many factors were there. So we discussed in the last class regarding them. Now today we will be discussing about all those things. It's over. So now before going to the next set of topics related to this chapter, that is the various types of reaction. Previously we did we read about the factors and properties and the features of the chemical reaction, and now we will be discussing about the various types of reaction. But before going that, I hope you have gone through the chapter, or rather gone through the portion which I discussed in the previous lecture or in the previous class. And I hope that nothing is, it's too much difficult for you people to understand. And still, if you're having anything that you haven't understood the things properly, what should I say? You need a repeat explanation, so you can inform me, or rather, once again, I'll go through after the completion of this chapter. I'll once again go through these points again, so that it will be a recapitulation of what we have done, or rather not only this chapter, the previous also, what we have done previously until now. Okay, so let us continue with this chapter, and as I said, I will be doing today the types of chemical reaction. As you can see, there are basically four major types of a chemical reaction. The first one is combination reaction. The second one, decomposition reaction. The third one, displacement reaction. And the fourth, double displacement or double decomposition reaction. Over here, I have shown you, or rather I've given in points. Later on, I will be discussing each and every reaction in detail. All right? Let's start with the first reaction, that is combination reaction. The way the word combination, you can easily understand, it's an English word, and the meaning is also related to the very simple English meaning, that is to combine. Simply, in simple words, that is to combine. Now, who will combine? Combination reaction, as the word itself. Now we have the first word, combination. That means it will be combine. It will combine. Who will combine? Substances will combine, of course, right? Substances will combine. Now, who are the substances? Now, just don't mug up each and everything. If you can clarify, or if you can remember the points like this way, it will be much more easier for you to understand and much more easier to remember. What? That I'll just go by the name. That's all. And you will see that automatically all the features, all the points, and what you have to write, each and everything will be there in front of you. And you don't have to memorize each and everything by heart. It's automatic. It will come automatically. So the first is, go by the word combination. What does combination, English word combination, means? To combine. Clear? Who will combine means merging, right? Combine means merging. Two things will merge together. That is combine, combination. Okay? It can be two. It can be two, more than two. But minimum two required. Minimum two required for anything to combine. So minimum two, maximum nobody knows. Leave it out. So minimum two substances. So we are dealing over here with two substances. So two substances will combine, or more substance can. So two will combine. Now, who will combine? Substances will combine. Now, why they will combine? Because it's a reaction going on. Why they will combine? Because it's a reaction going on. Now, what type of substance will combine? Rather, it's better to say first combine, next who will combine? Substances will combine. Third, what type of substances will combine? Each and every substance can combine. No. Then which two substances will combine? They have to be chemical substances. They have to be chemical substances. Right? Chemical substances, they will combine together. Okay. The next question which will come, that is why they will combine. Now, if I, for example, if I ask you a question, why will you eat? Why will you eat? You will tell me, sir, we are hungry for that reason. Definitely. That means there is a condition. You are only eating the food because there has been a situation. The surrounding is forcing you to have food. There is a certain condition which is forcing you to have food. So for that reason, those two substances will combine. Why you are switching on this fan? Because you are feeling hot. Why you are switching on the light? So we cannot see. So when there is a condition which is forcing you to do a certain work, definitely you will do that work because the surrounding is forcing you to do that work. So definitely over here, the two substances will combine because the surrounding is forcing those substances to combine or to merge. The next, how they will combine. The next question, how? Rather, in what way they will combine. They will stay together. That's all. No. They will react. Combination means the combination over here is react. And the word reaction, that means chemical substances, they will react. And how they will react, that is entirely, that depends on the two substances. Clear? So, combination reaction, two or more substances will combine together to form one substance, and it's also called a synthesis reaction. Synthesis reaction. Synthesis means to produce. Synthesis, one new substance will produce. Synthesis reaction. So as you can see, the example given, it's a format, it's a basic general structure of combination reaction. Two substances, A and B, they will combine together and they will form one product, that's C. As we know that on the left hand side of an arrow we write the reactants, and on the right hand side of the arrow we write the products. On the left hand side we are having two reactants or two substances. On the right hand side only one substance. Clear? So examples given that iron reacts with chlorine to give ferric chloride. So iron plus, so Fe plus Cl to giving FeCl3. Aluminium reacts with oxygen to form aluminium oxide. Aluminium oxide, so Al2O3. Okay. Now, if you notice one thing, that first regarding to this reaction, I have given a definition. I have given, along with the definition, if any other names of the reaction available, I've given that also. Followed by an example which includes the format or the general pattern of the reaction, or the general pattern of the reaction, of course. Followed by a prominent example. With that example, that reaction is balanced. The state of the reaction, the state of the reactants as well as the products, they're also mentioned, and the name of the reactants and the products mentioned. So my suggestion is when you will be writing, suppose in the exam this definition comes, explain combination reaction. So my suggestion is, it will, if you can write like this way, that is the definition, the additional name of the reaction, the general format of the reaction, one example in a balanced reaction with the state mentioned and the name of the reactants and the products. If a student can write like this way, that will be a complete, total, complete answer where the examiner or whoever will be checking your papers will not be able to deduct marks. That will be a full proof answer. All right? Okay. Moving on to the next reaction, that is, okay, before going to the next reaction, there is another format. As I said, multiple substances can react to form one substance. I've shown you another example. That's previously it was A plus B giving C as the product. Those two reactants reacting together to give one product. Now I've shown you three reactants reacting together to form one product. So three reactants reacting together to form one product. What's that? So example is bubbling excess carbon dioxide through sodium hydroxide solution. So the first reaction which is given is sodium hydroxide reacts with, that's the first step. When sodium hydroxide reacts with carbon dioxide to give sodium carbonate and water. That is the first step. That's the first step. The second step, when excess carbon dioxide, example is excess carbon dioxide. So when excess carbon dioxide is passed through the solution, then what happens? This is sodium carbonate, which was there in the medium. It's already there in the medium. Water, it's already there in the medium. And what I'm doing, excess carbon dioxide, it forms sodium bicarbonate. So one substance, so sodium carbonate, water, carbon dioxide giving one substance. So A plus B plus C, that's the format, giving D at the product. Clear? Okay. Coming to the next reaction, decomposition reaction. The word itself says decompose, that means to break down. We have heard this word, if not in, what should I say, chemistry, then in biology definitely. Decompose, that means breaking down, break down. Okay, into simpler forms, into simpler substances. That's called to decompose. So a chemical reaction in which a compound decomposes, that means breaks into simpler forms. And how it will break? Do we need to hammer it? Shall we hammer the compound and we will be breaking that one into fine substance? Definitely not. Definitely not. We will not be hammering that one, or we will not be pressing that one. We will take that one into our hand and we will just press it and we will break that one. So by the application of such pressure, so sir, compounds are breaking. No, definitely not. We will not use hammer, or not we will use our hand, or another option. You may tell me, sir, can we use scissors? So please do not come up with these sort of ideas. So all these hammers, scissors, it will not work. Okay, so it is basically by the application of heat or any other forms of energy. So we have to provide energy. Your pressure will not work. Pressure by hammer or scissor, all these sort of things will not work over here. You have to use heat or any other forms of energy. It can be in the form of normal heat energy. It can be electrical energy. It can be sound energy. So by the application of energy of many other different forms of energies available, and by the application of these energies, if the compound breaks down into simpler substance, that means simpler means, for example, a compound, you are writing, for example, the molecular formula of one particular compound is having 10 atoms of A, 6 atoms of B, and 5 atoms of C. So all these things, so many atoms in one particular compound. And after breaking down, it is showing that 2 atoms of A, 3 atoms of B, followed by plus 1 atom of C. So the number of atoms is getting reduced in one particular, when the products are forming, in a particular, the compounds which are forming as a product, in those compounds, in the product section, the number of atoms of individual element has gone down, reduced. And that is what you call as to decompose, breaking. We are breaking. So you can check it out with the, for example, the format given, that's A, by the application, I have not written over there, but it's application of heat or any other energies. It will form, it will break down into B and C, or it can be D also, or E also. So one substance can broken down into neither, it's not that I have shown as B and C, you can also add plus D, plus E, plus F, no problem. Not at all. It's no problem at all. It's absolutely perfect. What the example says, examples also over here given. So this is called decomposition. It's also having a name. It's called, since with most of the reactions are being carried out by the application of heat. So it's called thermal decomposition. Most of the reactions in the decomposition section is carried out by the application of heat, and it's called thermal decomposition. Now, examples, you can see that H2O2, hydrogen peroxide, if you keep that one, probably if you heat that one, you'll get water and oxygen. If you keep hydrogen peroxide under sunlight, that means I'm using light as a source of energy, then also it will break down into water and oxygen. If you see silver nitrate, if we heat silver nitrate, then we will get silver plus nitrogen dioxide plus oxygen. So 3. In the previous, as I said, that B plus C I have shown, if you write B plus C plus D, and also not an issue. So silver decomposing into silver nitrate, breaking down into silver plus nitrogen dioxide plus oxygen oxygen. So 3 products from one substance. This is decomposition. So, or we can also ask thermal decomposition. Now the next, another example is given over here. That's called ammonium chloride. It's breaking down. If you heat ammonium chloride, two gases will come out: ammonia as well as hydrogen chloride gas. And these ammonia and hydrogen chloride gas, if they combine once again, since it's in the presence of heat, if they combine once again in the absence of heat, if they combine, then once again they will combine together to form ammonium chloride back. So ammonia plus hydrogen chloride, you will get ammonium chloride plus, ammonia, you will get ammonium chloride. And under heat, thermal decomposition, it breaks down into ammonia plus hydrogen chloride. But now there is an interesting thing over here. The interesting thing is, if you notice the rest reaction, that's only having one particular arrow. With ammonium chloride, it's having a reversible sign. Now this arrow is basically known as thermal dissociation. But in the previous two, it's called thermal decomposition. There's a very smaller difference between thermal decomposition and thermal dissociation. The primary and the very simpler difference between a very small difference is the products formed in the thermal decomposition, that means the breaking of bonds in thermal decomposition reaction, are almost permanent. So if we combine water and oxygen, we will not get, it's not a reversible reaction. So we will not get hydrogen peroxide. Silver nitrate, when it gets decomposed to silver, nitrogen dioxide and oxygen, so if we combine silver, nitrogen dioxide and oxygen, we will not get back the silver nitrate in this normal form. So we are heating that one. After heating, we are getting the silver, nitrogen dioxide and oxygen. After cooling, if we are thinking that we will get back this silver nitrate, I'm very sorry, we will not get back. But with ammonium chloride, we are getting back, and we are having this one. Basically, this is thermal dissociation. So this is the difference between thermal decomposition and thermal dissociation. Understood? Okay. Now moving on to the next reaction, moving on to the next set of reaction, that is simple displacement or displacement reaction, makes the same thing, no difference. Simple displacement reaction or displacement reaction is the same thing. What's that? Over here in a chemical reaction, an element will react with a compound. An element will react with a compound to form a new compound and a new element as a product. Clear? So, chemical reaction in which one element is substituted in place of another element. So there will be a substitution. Displacement. That means I will replace one's position, I will take that one. Okay? And a new compound will form. New compound means new compound will form along with the formation of a new element. As the structure says that A plus B is an element reacting with B is a compound to give C as a compound and D as an element. A little bit confused. So let's continue with an example. Let's consider an example that's given. Zinc in the solid state and it reacts with hydrochloric acid. It's compound. So zinc, it's an element taken in the solid state. It reacts with hydrochloric acid, which is in the solution state, in the aqueous state. It's a compound. So zinc, what it forms? Zinc chloride. So zinc replaces, rather displaces, better to say displace. Zinc displaces hydrogen from hydrochloric acid to react with chlorine to form zinc chloride, and hydrogen gas will come out from the solution, from the reaction medium. So zinc will replace, is displacing hydrogen from hydrochloric acid to form zinc chloride and hydrogen. So hydrogen is an element. Zinc chloride, it's ZnCl2, it's a compound. Zinc is an element and hydrochloric acid is a compound. So from one element, zinc, it's forming another new element, hydrogen. Okay, new element is formed. The next we are having is Fe2O3 plus carbon. You can see it's ferric oxide reacts with carbon. It's basically one of the reduction reactions. So Fe2O3, ferric oxide reacts with carbon. It forms iron plus carbon dioxide. So carbon is displacing iron. Carbon is displacing iron to react with oxygen to form carbon dioxide, and a new element is formed. So previously the element was carbon, and after the reaction the element is iron. And what the compound formed? Previously carbon was an element and ferric oxide was a compound, and after the reaction iron is the element and carbon dioxide is the compound. Clear? The next is double displacement reaction. Double displacement. Over here now, the situation is two compounds will react together. Two compounds will react together to form what it will form. The two compounds will react together to form two or more new compounds of the products. So two compounds will react together to form either two compounds, which are two new compounds, or more than two. It can be 3 or 4 new compounds as the products. This double displacement reaction is also called as double decomposition reaction. So A plus B. So in the previous reaction, if you see, it was one element was reacting with a compound. Now it's two compounds are reacting. So compound 1 reacts with compound 2 to give C and D both are compounds. Though it's not written, but C and D both are compounds. You can also write C plus D plus E plus F, no problem. All are compounds. A plus B plus C plus giving D plus E plus F, that also possible. That also double displacement reaction. So compounds reacting together to form new compounds, 2 or more new compounds. It's called double displacement or double decomposition reaction. So barium chloride, it's a compound. Sodium sulfate, that is also a compound. The state it's mentioned, aqueous, means in the solution state. So we are taking barium chloride solution, and it's reacting with sodium sulfate solution to give barium sulfate. Solid means it's a precipitate it's forming. Barium sulfate, it's forming a precipitate in the reaction. So for that reason, it's written solid. Plus sodium chloride, aqueous. Lead nitrate, we are taking the aqueous solution. It reacts with potassium iodide, Ki, to give potassium nitrate, KNO3, plus lead iodide, which is a solid. That means precipitates out from the reaction system. Precipitates out from the reaction system. All right. So this is what about double displacement or double decomposition. Now, there are a few more types of double displacement reaction. There are few more types of double displacement reaction. What are those types? The first is precipitation reaction. The second is neutralization reaction. The third is hydrolysis reaction. So the first one type of double decomposition or double displacement reaction is precipitation reaction. The second, neutralization reaction. The third, hydrolysis reaction. Let's move on to that part. The first, as I said, precipitation reaction. By the name itself, precipitation, we can understand that when the reaction will go on and after the completion of the reaction, we will be able to find an insoluble residue within the reaction medium called the precipitate. So when two compounds are reacting together, so they will form an insoluble residue. That means they will form an insoluble solid, insoluble residue. Residue means insoluble, but still insoluble solid or residue called the precipitate within the reaction medium. Example, silver nitrate, AgNO3 silver nitrate reacts with potassium chloride to give silver chloride, which is the precipitate or the insoluble substance, the residue left out, plus potassium nitrate, KNO3. Ferric chloride reacts with sodium hydroxide to give ferric hydroxide plus sodium chloride. Ferric hydroxide is insoluble, the precipitate. Neutralization reaction. The neutralization reaction is a very simple one where an acid and a base react to form salt and water. Acid and the base react to form salt and water. So we have taken sodium hydroxide, it's a base. HCl, hydrochloric acid, by the name itself it's an acid. What it forms? NaCl, which is a salt, and H2O, it's water. Aluminium hydroxide, it's a hydroxide, it's a base. HNO3, nitric acid, it's an acid. It forms aluminium nitrate, it's a salt, and H2O, it's water. So it's going by the definition itself. That the reaction in which acid and base react to form salt and water is called it's called neutralization reaction. Now this neutralization reaction, if you notice, this neutralization reaction is highly significant in our daily life. It's highly significant, this reaction. And that is when we suffer from acidity. What do we take? We take antacids. We consume medicines, antacids. We are suffering from acidity. What are antacids? By the name itself, it says anti-acids. Antacids, basically, if you break down, it's anti-acid. That means the opposite of acids. That medicine is opposite to acids. So what we consume, those are basically bases. We normally consume bases which actually reacts with the acid within the stomach to form salt and water, and hence we get relief from the acidity. The next is hydrolysis. This reaction where salt and water react to form an acid and a base, or an acidic solution or a basic solution. This hydrolysis is basically the reverse of neutralization reaction. The hydrolysis reaction is basically the reverse of neutralization reaction. Or so it is said that it will form acid and a base, or an acidic solution or a basic solution. So if you notice the first one, zinc sulfate plus water. Zinc sulfate is salt, water is water. Zinc hydroxide, it's a base, and H2SO4 is an acid. So base and acid formation. Methyl acetate is an organic compound known as under the class of esters. So if esters react with water, they form acetic acid and methyl alcohol, that is making the solution acidic. Acetic acid plus methyl alcohol, they are making the solution acidic. The previous one also, is it acidic? Definitely it's slightly acidic because zinc hydroxide is a weaker base in comparison to sulfuric acid. So it's a slightly acidic, but it's forming base and a acid. The next one, base, it's forming alcohol and acid, so it's totally in a slight acidic solution. I hope till this much it's clear to you. Moving on to the next part, a small portion left out, that is when we are having reactions based on energy change. Reactions based on energy change, that is chemical reaction that releases energy mostly through heat and sometimes light. That means when a reaction is taking place, you can feel that the container in which the reaction is going on, it's becoming pretty hot. That means huge amount of heat is getting liberated out from the system. That means by the reaction, the reactant itself is producing heat, a lot of amount of heat. They're releasing out, and hence the system, the container in which the reaction is going on, it's becoming hot. So those are exothermic reactions. That word exo means out and therm means heat. So out and heat. So heat out. Heat out. Therm means heat. Exo means out. Examples given. The C6H10O5 is basically a molecular formula of cellulose. Though in your book you may find reactions, simpler reactions. This time for this I've utilized a different sort of reactions, a slightly complex reactions. And I hope that I'll hope that you will be able to cope up with these reactions. I trust you, and I'll hope that you will be able to cope up with these reactions. Don't panic. So C6H10O5 plus 6O2, it's giving 6CO2 plus, that means burning of cellulose. Cellulose, where it's present, cellulose? Cellulose is present in plants. Yes, cellulose is present in plants. So when we burn wood, it is forming carbon dioxide and water vapor, and along with that, a lot amount of heat. The next reaction, if you see, it's ammonium perchlorate, NH4Cl4, ammonium perchlorate. When it reacts with aluminium, it forms alumina plus hydrogen chloride gas, nitrogen, and water vapor, and a lot of amount of heat. This reaction is common with rockets. Okay? So these are exothermic reactions. The next, endothermic reaction. That's the opposite of exothermic. Exo means out, so endo means in. And therm automatically heat. So heat in. That means heat will not come out, heat will be within the system. That means the reaction. So the reaction needs heat. So previously the reaction was giving us heat. Over here we have to give heat. The reaction needs heat from us to carry on the reaction. So calcium carbonate. So the supply of heat can be through, supply of energy can be absorbed energy. It can be through heat or sometimes light, or it can be through sound also. So absorption of energy. Energy mostly it can be through heat, light or sound or any other sources. So calcium carbonate, when it breaks, we have to heat that one. That means it does not break easily. So if we heat that one, we are providing the heat to the medium, and hence it's forming calcium oxide and carbon dioxide. Nitrogen plus oxygen, to form nitric oxide, it needs heat. This reaction is common in, during thunderstorms, lightning. It forms nitric oxide. This is nitric oxide, NO2, nitric oxide. The temperature almost 3000 degrees Celsius. Nitrogen reacts with oxygen. So a huge amount of energy is required for nitrogen and oxygen to combine to form nitric oxide. Similarly, calcium carbonate decomposition, it needs a lot of amount of heat. So it is endothermic, so it is endothermic reaction. Now you can tell me thermal decomposition. Now this concludes that thermal decomposition reactions are endothermic. Yes, thermal decomposition, because we are heating those substances and we are getting products, and hence examples of thermal decomposition reaction can be utilized as endothermic reactions. Okay, so with this I will stop today with this chapter, and in the next class we will be probably this chapter with this endothermic reaction. The chapter is almost over, and in the next class I will be definitely discussing with the other queries of yours, other problem areas, and with any other sections which need to be repeated, and the question answers of the chapter, exercises of the chapter. Until that time, I'm giving you a homework, exercise 2A, page number 22 of the book. The materials have already been provided to you. All right, so keep your work updated, and till the next class, thank you so much. Stay safe and take a very good care of yourself. All right, thank you.